So this video on BMQ question 1, we are talking about vectors 2 tutorial BMQ question 1. First, find a vector equation of the line passing through negative 1, 3, 2, 1a, and parallel to the vector 4, negative 1, and 2. Okay, so we call this quick recap that the vector equation of a line. Okay, what we have is that this equation of a line, we need a fixed position vector on the plane. So position vector is somewhere with reference to the origin, right? The position vector of the plane, this would be negative 1, 3, 2. Right, so this will be negative 1, 3, 2. Right, so this will be a point A, right? And parallel to the vector 4, negative 1, 2. So here we have this line here to be parallel to the free vector, which is 4, negative 1, 2. 4, negative 1, 2. Alright, so you can see that we have a fixed point, fixed position vector, and it's parallel to the line, and we know that the equation of a line is just equals to this is just equals to a plus lambda m, just lambda m, where m is the position, is a free vector or the direction vector. So this is the direction vector, right? And a would be the position vector of that lies on the line. Alright, so with this we are ready to just quickly plug in the question. So the answer to part A, right, would just be negative 1, 3, 2, alright, A plus lambda m, which is 4, negative 1, 2. Now because we know that if these two lines are parallel, it means that they have the same direction vector. So the direction vector of line 1 will also be 4, negative 1, 2, right? So this would be the answer for 1a. Okay, next will be an equation of the line passing through the origin and 2, 1, negative 5. Right, so we know that this is a line that passes through a position vector 2, 1, negative 5. Right, and it's a reference to the origin. Okay, and it also passes through. So the origin, as we know, this is 0, 0, 0. On top of that, it passes through the position vector 2, 1, negative 5. So it also means that because 2, 1, negative 5 itself is a position vector, right? And this could be the vector 2, 1, 2, 1, negative 5. Right? So this just means that 2, 1, negative 5 is also can be the direction vector of this line. Right? So very quickly, if you were to find the direction vector, which is using r equals to a plus lambda m, you can see that this will just be equals to 2, 1, negative 5. Right? And what is a? A will just be any point, or we can just use 0, 0, 0. Right? And very quickly, we can say that the equation of the line 0, 0 is nothing, so it's, we don't even write it down. Alright, so it's just equals to 0, 0, 0, right, plus lambda 2, 1, negative 5. It's just equals to lambda 2, 1, negative 5. Yep, and that's the equation for BMQ2B. Okay, how about BMQ1B? How about 1C? Okay, 1C we want it passes through 3, 1, 4, parallel to the line whose equation is 2 minus t1 minus 1 and t. Alright, so let's write out the next line. This line, okay, the first line that we have, r equals to 2 minus t minus 1 and t. Alright, we can also rewrite this as r equals to 2, negative 1, 0, plus t, negative 1. So negative t will as t, negative 1. Negative 1, it means that there's nothing to do with t. T over here, I'll put it as 1. Right, so this can also be rewritten in this method, that the line that's a parallel to. And okay, with that, and how about 3, 1, 4? And there's another line here. So this line passes through the position vector 3, 1, 4. Okay, and is parallel to the line whose equation is as follows: 2 minus c negative 1t. This also means that since two lines are parallel, they have the same direction vector, and I can say that the direction vector here, right, is equals to negative 1, 0, 1. And with that, very quickly over here, get a set coils R2. The equation of my line will be equals to 314. Add together with lambda. Direction vector is negative 1, 0, 1. Okay, this is for BMQ1C. How about for BMQ1D? For 1D, 0, negative 425, perpendicular to 4, negative 2, and the second equation. Alright, so it's perpendicular to both. So let me just think about writing these two lines out. Right, so I can see that the position vector of the first line, right, this is equals to okay, so let's go side right of the first one, right. Okay, this r is equals to 4 minus 1, 2 plus lambda I and 3k, so it's 1, 0, 3. This is for the first line. For another line, I have the following. Alright, so the following is 4 minus 1, 2 plus mu of 8, 3, negative 3. So I need a point. I have another line here, somewhere here. Okay, passes through the position vector. So sorry, let me write again. Position vector 0, negative 2, 5, and the direction by this line here is perpendicular to these two lines, right? So I need a direction vector from this line in order to, for me, I have a position vector. So what I do is for this line, I need a direction vector. Alright, how do I find a direction vector of this line? I'm going to use the red and the blue line. Okay, because I know that it's perpendicular to both the blue and the red line, what I can do is, if I use the blue and red line to do vector product, so what I can do is I can take the direction vector of the blue and red line to get the direction vector of the green line. Right, so how do I go about doing this? What I'm going to do is very simple. I am going to do vector product. In order for me to get a direction vector perpendicular to both blue and red, what I'll do is I'll do vector product of the two direction vectors of a red and blue line. So with that, I will do the following. Right, I will just take 1, 0, 3 direction vector of the first line, 8, 3, negative 3 direction vector of the second line, and I'll do vector product. Okay, and from here you should be able to get negative 9, 27, 3. Right, or okay, we can also simplify as a negative 3, 9, 1. Since for direction vector is not unique, okay, you can scale it now. Right, so equation of the line, since it passes through 0 to negative 5, right? So it's 0 to negative 5 plus lambda negative 3, 9,